It's your friendly math tutor, Miss C, here to unlock the magic of solving systems of equations using the elimination method. You might be wondering why elimination for this particular system? Well, if we look at the coefficients in front of both of our variables, 4 and 7 for x, 3 and 2 for y, substitution doesn't work very well. Like that'd be a lot of fractions. So we're going to use elimination instead. And then we just need to choose, our first step is to choose the variable to eliminate. I'm going to pick y just because the coefficients are smaller. So I'm going to be looking to get rid of the y values. So when I do that, I need to get essentially the inverse operation of the same number. So what that means is I'm looking for the smallest possible number that both 3 and 2 go into, and that's what I'm going to turn these numbers into. But I can't just multiply a single term by that number. I have to do the whole equation. So let's go ahead and go. I'm going to try to get one of these equations to equal 6y. I'm going to try to get the other one to equal negative 6y. So I'm going to go ahead and start by multiplying the top equation by positive 2. So this is going to be my equation that has the y term equal to 6y. So when I do that, I'm going to distribute 2 to every single term. I'm going to write that over here. So I end up with 8x plus 6y equals 14. Since this is 6y right here, I now need to make this equation such that my y term equals negative 6y. So I'm going to go ahead and multiply this one by negative 3, because when I multiply my 2y by negative 3, I get negative 6y. So when I do that, I get negative 21x minus 6y equals 12. All right, so my first check that I did this right is going to be that when I look at my y terms, does 6y minus 6y equals 0? It does. I correctly eliminated y. So now I'm just going to combine the equations. So 8x minus 21x is negative 13x equals 14 plus 12 is 28. And now I'm just going to get x by itself. The way I do that is I divide by 13 on both sides, and x equals negative 2. So that is my x value. Now, all I need to do is plug that negative 2 value in for x in one of my equations. You can choose the equation you like best. I'm just going to pick the top one. So everywhere I see x, I'm going to substitute negative 2. So my equation is 4. This is where my negative 2 is going to go. Plus 3y equals 7. I'm going to just change the color so you can clearly see where I am substituting that negative 2. There we go. That's where it went. And now I just simplify. 4 times negative 2 is negative 8 plus 3y equals 7. My goal is to isolate y or get it by itself. So to do that, I'm going to do PEMDAS backwards. I'm going to add 8 to both sides. So now that makes a 0. So I have 3y equals 15. To get y by itself, I'm going to do the inverse operation of multiplying, which is division. So I'm dividing by 3 on both sides. And I run out of room, so I'm coming over here. So y equals positive 5. So my solution to this equation is x equals negative 2, y equals negative 5. This is also called the point of intersection. So this is where the two lines would meet if they were graphed. And we could also write that as a coordinate pair like this. So you can write your answers as what I have in the boxes, or you can write them like this.